Okay, so hopefully you checked your answers and you got x to equal 0.5 and x to equal 1.5. Now, I've already mentioned this, but one thing to be careful of is you may not convert to log form unless the base is alone. So what not to do? Make sure to convert to log form after your base is alone. The reason I drew that arrow is just to show you log form. So looking at letter A, we're going to ask, is our base alone? Meaning, is there any number that's been added or subtracted to the base? And looking at letter A, no, there's nothing that's been added or subtracted to that number. Letter B does show a number that's been added or subtracted to the base, and that we're going to have to deal with in a moment. But looking at letter A here, you can have an exponent with some numbers in it. But having the base alone allows you to just convert it to log form. So we have log base 3 of 101 is equal to x plus 4. Now we know that we can have this, or this is a number on our calculator, log base 3 of 101. So if we want to solve for x with one line on our calculator, we can just subtract 4 and then plug this into our calculator. Log base 3 of 101, we're going to plug that in with one button. We're going to subtract 4 from it, and that will equal our x. So we plug that in, and we go to Math under option A, and we're going to type in 3, 101, and then I'm going to subtract 4 from it. Oops, I was going to do that in one line, but I ended up doing it in 2. You can just, after you close the parentheses with the 101, just subtract 4 from it, and you have your answer, 0.201. So x is equal to 0.201. And before I box my answer, I should check it. So let's see, is 3 raised to the, I want that value for x, so I'm going to take that from the previous line, that answer, and remember that second negative to take that answer, plus 4. Is that really 101? Yes, it is. So I check it off, and I have that. Now, letter B is what we have to be careful about. I can't just right away convert this into log form. That would be what not to do. I can't convert it into log form because when I convert it into log form, I'm just working with a log base of 10, not this plus 8 here. So what am I going to do first? I'm going to subtract the 8 to both sides, and that gives me 10 raised to the x power is equal to 1,000. Now, you don't have to use logs on this. If you know that 10 to the third power is 1,000, then yeah, you could just check that. Or you could just say what you know, x is equal to 3. But one thing I do suggest to you is make sure if you are using guess and check, you check your answer back into the original equation. And actually, I just suggest that always. So we have 8 plus 10 raised to the third power. Yes, it does equal 1,008. So we know that we've checked it out. So hopefully what you've seen from page 26 and 27 in the notes is if something starts in exponent form, so let's write that. If equation starts in exponent form, convert to log form to solve for x. And the only thing you have to be careful when working with that is any bases must be alone on one side of the equation. Okay, this is if an equation starts in exponent form. On the next page, we look at what do you do if an equation starts in log form, has a log with it. And as you might have even already guessed, if something starts in log form, you're going to convert it back to exponent form to get the variable alone. Only a few things that you have to be aware of. All logs have to be to one side of the equation in order for you to convert, and all logs have to be combined into a single expression in order for you to be able to then convert it to exponent form. So let's look at example 3. The log is by itself, it's on one side of the equation. So we can actually jump to step 3 and convert it to exponent form. But wait a minute, there's no base given to me. what base is really there if none is written in? Hopefully you're thinking to yourself 10. That's known as the common logarithm. So I'm going to mark that in as a base of 10. And now I convert it to exponent form. So I use my base 10 raised to the exponent, which is always the answer of the log, will equal my 2x minus 2. Now this is just an equation that I can use to get x by itself. So 10 to the fourth is 1 with 4 zeros, also known as 10,000. That's equal to 2x minus 2. Add 2 to both sides, giving me 10,002 is equal to 2 times x. Divide both sides by 2, and I have that x is equal to 5,001. But before I box that, let me make sure that I check it. So looking at log base 10, remember that's just the log given to you on your calculator. No base is shown, but we understand it to be a base of 10. So we have log of 2 times 5,001, subtract 2, and see, does that come out to equal 4? Check, it does. So I'm going to box it and check. It's good. Okay, letter B. Letter B, the log is alone. Perfect. So it starts in log form. To get that x by itself, I'm going to convert it to exponent form. My base, again, is 10. So I have base 10 raised to the negative first power is equal to 7 minus 2x. Now 10 to the negative first, you guys know that to be 1 over 10 to the first, which is the same as 1/10 or 0.1. So I have 0.1 or 0.10 is equal to 7 minus 2x. Now I just get x by itself. So subtract 7, or you could think 7.0 to both sides, giving me negative 6.9 is equal to negative 2 times x. Divide both sides by negative 2. A negative divided by a negative is a positive, and I'll see that x is equal to 3.45. But again, before I box that, I want to check it. So I have log of 7 minus 2 times 3.45, and see, does that really equal negative 1? Sweet, it does. So I'm going to box that and check it. Please be aware the check step is probably the most important step. I actually had to redo this video because I made 2 mistakes and I found it while I was doing the video using the check step. So I just decided rather than show you the mistake, I'd just redo the video. But I do want you to see the importance of the check step. Alright, so let's flip it over. Example 4. Now remember, all logs have to be to one side of the equation, so they are, but they have to be combined into a single log. So when I combine these into a single log, I need to use the properties that we looked at on Wednesday. If I look at 2 logs that have a minus sign between them, to convert them to one log, we use the quotient property. So I'm going to use division, log of 6 divided by 3x, to combine those 2 logs into one, and that's equal to negative 2. Now that I've combined those into one, now I can convert it to exponent form. No base written there, so I know my base is 10. So I'm going to write down my base 10 to the negative second power is equal to 6 over 3x. 10 to the negative second power, that's the same as 1 over 10 squared, or 1 over 100, which is just 1/100th, 0.01. If you weren't sure of that, you could do that on your calculator. Oh yeah, it's 0.01. So that's equal to 6 over 3x. Now in solving for x, x right now is in the denominator. Can't have x in the denominator. I need to get it out. So 6 has been divided by 3x. To undo division, we do multiplication. So I'm going to multiply both sides by 3x over 1, or just 3x. And multiply 3 times 0.01 to give me 0.03. I should have known that. 0.03x. is equal to 6. Now I have x not in the denominator, and what undoes multiplication? Division. So I would divide both sides by 0.03, and I will find x is equal to 200. But again, before I box that, let's check it. Is log of 6, close that parentheses because that's one log, minus log of 3 times 200, is that really equal to -2? Sweet it is. So I'm going to box it. Beautiful. All right. Letter B is similar, but dun 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 dun, we see a 3 in front of the log. Oh no. That suggests the power property. How do I know when I use the power property? Well, let's review from yesterday. When using the power property, when combining two logs, you use it first. When expanding, you use it last. So I'm combining two logs. We use it first. And let's be reminded, what is the power property again? Here's an example of what it looks like. 3 times log of 2 is the same as, we use it, we make it back into a power, log of 2 cubed. Okay, so there's that power property. I'm combining, I need to use it first. So I take that 3, raise it back into a power for the x. So I have log of x cubed minus log of 2 is equal to 5. Now that I've used that power property, I look at the next property, which I have a minus sign, so that's the quotient property. Use division. So I have log of x cubed divided by 2 is equal to 5. Now there's no base written there, so I know my base is 10. Now that I have all logs to one side of the equation and combined into one, to get the variable alone, you convert into exponent form. So my base is 10. 10 raised to the 5th power will equal x cubed divided by 2. 10 to the 5th is 1 with 5 zeros, 2, 3, 4, 5, also known as 100,000, is equal to x cubed over 2. Multiply both sides by 2 to get x alone. So we have 200,000 is equal to x cubed. What undoes a cube? A cubed root. So we're going to take the cubed root of both sides. On our calculator, we're going to go to math option 3. Cubed root of 200,000 is 58.480. 58.480. So remember, it's not enough to just box it. We got to check it. So plug it back into the original equation is 3 times log of our answer for x, so that was in the previous line, minus log of 2. Does that really equal 5? Yes. Check it off. Alright guys, you may start your homework. Have a good day.